So this is the last type of conversion that you will need to do, and it doesn't happen a lot of time. Okay, so again, in this question, we're dealing with a speed time graph. So we do remember to write out the feature first. So the gradient is acceleration. The area under graph is the distance traveled. Okay, so you at this stage, right? I think you will be able to try part A and part B. The part A is the gradient portion. So the gradient for the first 20 seconds, which is 16 meter per second over 20 seconds. So that will be 0.8 meter per second square. Okay, the distance traveled will be the area. So I will leave it to you to calculate the area. So it's basically the area of a square, a rectangle, and a triangle or a trapezium. Okay, the focus in this question is to convert to acceleration. So how am I going to convert to acceleration? So which feature should I use to convert? So acceleration come from the gradient. So apparently I should use gradient to convert. So like in the previous question, if I want to convert to distance come from area. So I'm converting using area. So here I'm going to calculate the gradient, which already calculated that's a 0.8. This gradient is a 0. So now you also got to calculate this gradient. Okay, so if you calculate this gradient, you will get a negative gradient. Okay, this part is 16 and this part is 6. So if you convert the gradient, right, it will look like this. So like this is 0.8. This is 0. And this part is somewhere like minus 2.67. So there must be when you're doing the conversion, right, there must be a certain feature you use to convert. So in this case, speed to acceleration. I'm using gradient because on the speed time graph, gradient represents acceleration. So I'm using a gradient to convert. So like in the previous example, I need to convert to distance. Distance come from the area. That's why I'm using area to convert. So we are using the feature of the graph to convert accordingly. So this will be the main conversion. We don't have a lot of time you are asked to convert speed to acceleration. Most of the time is between speed to distance, distance to speed.